Here we're going to do an evaluation of the rear alignment on this HB20. It's a new car, okay? 2025, 2026. Just so you know, this car has never even had an oil change, okay? The car has less than 5,000 kilometers on it. So here's the thing, look. We're going to turn on the equipment here and we're going to use a simple device, a digital aligner without Wi-Fi, okay? So what happens, it's level here, look, the level is right here on the side, see? It's level here. So here's the thing, when you're going to do a rear alignment, you basically check three things. I just turned on the equipment here, and here on the other side, Ryan is already over there, and he has already turned on the equipment too. What happens? This equipment here, as I already mentioned, it's already on. It's leveled as well. See here? Perfect. And here's the thing. It's a simple digital device. Look at this. This is the equipment, digital, simple, without Wi-Fi communication. It's a very simple, very basic device. But if you truly understand what you're doing, you'll successfully complete the task with high quality, with great efficiency, and you will not find yourself falling short in any way. So what happens? Ryan turned on the lasers over there. Here's what happens. So we're going to see right here, when you work with rear alignment, exactly what you need to evaluate in that rear alignment process. Rear, okay? It could be this specific car or really any other vehicle. Of course, different cars will have various shapes, structures, and many types of suspension, such as a fixed axle or an independent setup. You got it, right? So what exactly happens in this situation? Essentially, what you're going to do is check three things. First is the camber, okay? So we're going to check that, and let's mark it right here on the surface. So then, how do we check the camber here? On our digital aligner, let's go here. I have a camber. It's negative, right rear, 1 degree and 5 minutes. Now, how do I know if the camber is good or not? Okay. So we go here, look, and Rian is going to do he's going to open up the app right here. Look, aligner guide, just a moment, aligner guide. Okay. Click on search. Now he's going to find the specific car model, the HB20. There it showed up right on the screen. Look, which one is that one over there? Look. HB20, 2025, 2026, 1.0. Click there, okay? And now we're going to check the rear measurements. Click on the rear, okay. So here, the rear camber, it can range from 0.42 to 1.42. See the negative here? That's the camber. So it's within range, 1.5, 1.10. In other words, the camber is within specification according to our app, all right? Now here on the rear wheel, on the rear driver's side, the camber is currently sitting at negative 0.55, which is almost 1 degree, okay? So it's also well within the manufacturer's specifications in the app, which can go up to 1.42, all right? Both sides have basically the same measurements, okay? 0.42 to 1.42 negative, same thing here. So both cambers are within specification. That's the first point. And what's the second point regarding camber, Rian? The second point, we're going to check the toe. Let's take a look here on the computer screen. Let's mark it here then. So we're going to get to let's mark here that the rear, we already know how to solve, how to measure, right? So you just need to turn on the equipment and level it. There's no detail to worry about there. Look, we've already checked the camber, right? If an adjustment needed to be made, that would be a different procedure. Logically, you would follow the same procedure to diagnose it. Then I would make the adjustment and repeat the reading afterwards. So for you, with this equipment, to take a camber reading, all you have to do is turn on the equipment. So once you've attached the clamp to the wheel and turned on the equipment without any kind of movement at all, you'll already be able to see the car's camber measurement right here, done. Without any kind of, and here, of course, at the level, okay? Move it here to the level. Now, for us to check the toe, it's there on the screen. It marked the toe. We're going to click to activate the laser. So to activate the laser here, when I press the laser here, this laser points over there to that arm. On that arm here, it's pointing. Please take a moment to notice that the laser originating from the transmitter over there is pointing directly and precisely at the 0 mark on the scale. Now we are going to carefully examine exactly how much light reflects onto the other sensor head positioned on the opposite side. Now, moving from that initial position over to this one, as we observe that head coming from there, the reflection is being cast from that point to here. At this specific location, it is reflecting at the coordinates of 2, -2. Since the machine is at the rear, you invert the signal. So in this case, it's at +2. Adding the measurement from there to the one from here, I have a total of +2 because 0 plus 2 is 2. So it's that simple. The alignment is done. And now we're going to follow the app again. So the alignment, the rear toe, it can be positive from 1.2 to 4.8. So it's at 2, which is within the specification. How do I know if it's negative or positive? Because there's no sign at all. When it's supposed to be negative, there's a minus sign in front. See? Just like the camber there. Since there's no sign at all, it's a positive number. So the toe can be set from 1.2 up to 4.8. It's showing 2 millimeters, so it's within the range, within the specification. We're going to mark here again that the check has already been done, right? Okay. And last but not least, the thrust angle. In fact, this thrust angle here causes a lot of loss of safety and a lot of instability. So it's a dangerous problem. If the car has a divergence in the thrust angle, the car becomes very unstable, very unsafe. And how do you check it with this type of equipment? Here it follows the same logic as if it were computerized with Wi-Fi communication and here digital readers. How does it work? So this laser that comes out from back here, see back here, it has to hit the plate in the front. Let's see what the reading is up front. Here it's pointing almost exactly at 10. So if you look closely at the positioning of this specific wheel right here, see? It's pointing more or less right at 10. On this wheel, on the other side, it has to point basically the same. So we can have an exact thrust angle. So look, just look. It's perfect. See? So both that specific wheel and this one right here are perfectly straight. Now, I want you to imagine that this is the rear axle. So when I have a misalignment, I'll have a crossing, where the plate in the front will show a difference from one side to the other. In this case, both plates landed in the exact same spot. So for us to be able to make this diagnosis here, the process is actually very simple. We just need to do this evaluation. So the camber is perfect. If it needed adjustment, we have several videos on how to make adjustments within our vehicle geometry course. Toe alignment, and lastly, the thrust angle, which is no less important, okay? Ryan, do you have anything to add, Ryan?
A very important detail is that we see a lot of cars where people pay attention to toe alignment and camber, but end up forgetting about the thrust angle. And then when someone aligns the rear and then moves on to align the front, those distorted values start to appear and the person doesn't know where they're coming from or how to fix them. So when it comes to rear end problems, you need to pay attention to these three details.
So coming back here, we've checked the three angles. I'm going to show this car here on the panel. It's a brand new car. It has 4,000 kilometers on it. I'm here in the car. You'll see. I'm just going to turn on its dashboard here. Take a look at this. It is a very clean car with exactly 4,800 kilometers on it. It has never had an oil change. It's a new car. So when you're going to align the front wheels using digital alignment, there's nothing stopping you from also checking the rear alignment. Some people think you can only do the rear alignment if you have a 4-head machine. Here we showed how you can do it. The rear alignment is performed with 2 sensor heads, and these same heads can then be moved to the front of the vehicle to perform the front alignment, right? One very important thing to keep in mind is that many times a rear alignment that is outside of the specifications, even if it is out of specification, may not actually show any visible tire wear. This happens because in the rear of the car, there is no engine traction, no heavy engine weight, no steering rotation, and the overall percentage of braking force is very low. So because of these factors, the car tends to have much less noticeable tire wear, even if there is a rear misalignment present. Unlike the front, which has significant traction, substantial engine weight, rotation, and braking, all of these various factors contribute to much faster and more accelerated tire wear.